This next panel will mechanically operate similarly to the morning panel in terms of the moderator, who I'm about to introduce, running the panel, and towards the end, questions from the audience, questions handed to our student runners. This is a very different panel from where we had this morning in that we're going from critical minerals to petroleum systems, but it's also very similar in the sense that we're looking at unconventional ways of doing things, unconventional ways of providing the energy and the resources we need to fuel society. So that's why we have this panel for the next hour. And I'll introduce to you the moderator of the panel, Dr. Tim Fisher. He's a new member of School of Energy Resources. He had a long career as a research scientist at Chevron, and we're pleased to have him here with us. Tim?
Well, thank you, Dr. Kasuba. Wow, what a pleasure that was to listen to Governor Gordon speak. Just real briefly, I've been involved in many universities, far too many when I was a student, but 3 as a student, 2 in my industry career. And this is the first time I've ever been in the same room as a governor, a vice president of operations at an oil and gas company, a state geologist. There's a botany professor in the room, I think earlier. Students from a wide range. So for the students out there, this is unique. This does not happen in most states. And it's not because Wyoming is small. It's because there is such a diverse group of interests and people solving really important problems. And just take a moment and enjoy it. This is really special. So I'm very happy that we got to see that. Thanks to the Wold family and Foundation for the sponsorship of this event. This is a great event. Thanks to Dr. Kazuba, Dr. Kotka for putting their efforts into this. And again, and this is hopefully not the last time they get thanked, Peyton and Christine have done a wonderful job putting this together. So thanks to them as well. I feel like to kick this off, this is an unconventional resource petroleum systems. We talked about unconventional systems earlier in the critical minerals session. When we talk about unconventional petroleum systems, we're talking about specifically organic-rich shales and mudstones that either self-source and produce petroleum from them or are sourced nearby. All right. So the good thing about unconventional petroleum systems is that when I started in the industry, maybe 12, 13, 14 years ago, we at Chevron, we thought of unconventional resources as shale gas. So something like the Marcellus Shale, where you're really looking for natural gas. Over the last 10 to 15 years, that development of unconventional reservoir assets has absolutely boomed, leading to the growth in crude oil production in the United States specifically. The United States is really the leader in the world at these unconventional resource production. And it's now gotten to the point where the United States is the leading producer of crude oil in the world. That's a pretty astounding increase over the last 10 years. This development has been driven by 2 forces. 1, technological innovation at all scales of the industry. And 2, a well-educated, multidisciplinary workforce dedicated in solving these problems. It is therefore fitting that we have this panel at the University of Wyoming because of everything I just mentioned. We have everything in one room, everything in one place, and we are well suited to bridge any silos that may exist elsewhere. We don't have those here. We can talk to each other. We can go across the campus and talk to each other. We can drive to Cheyenne and talk to somebody if we need to. All right. With that, let me introduce the people that we are going to talk to. 3 of these experts are in the room with us. First, at the end there is our own University of Wyoming professor, Dr. Tawfiq El-Shahabi. All right, thank you. He is an assistant professor in the Department of Energy and Petroleum Resources. Next to him, we have Joey Matoush. Matoush? Yes, I got it right the first time, so I should not question myself. He is the Vice President of Subsurface and Powder River Basin Assets at Anschutz. And then next to me is Andy Finley, geologist and partner at Goolsby, Finley & Associates and Encompass Energy Consulting Corporation. So I'd like to thank them all for being here. Thank you for having me. I'm going to ask for them to give about, a short an introduction to themselves. And specifically what we want to do is start addressing what they see as the main challenges that exist in unconventional oil and gas production as they introduce themselves, and then we'll move on from there. So I'm going to start with Andy, and then we'll go from Andy to Tawfik, and then back to Joey.
Thank you very much. Thank you, Jack and Peter, for inviting us here and for getting this group together. Thank you for attending. Thank you to John and Holly. So this is as everybody's been saying, this is a nice, diverse group where we can talk about a wide range of issues. And obviously, since we're a land-grant state, the ability to produce and extract minerals is very important to us. So I started about 34 years ago in this industry. I received my undergraduate degree at University of Illinois. I received my master's degree at University of Wyoming. And I started working after I received my degree. I had worked for a year with Exxon, and then I worked for Conoco here in Casper. And fortunately, with Conoco in 1991, I started drilling horizontal Bakken wells in the original Bakken play up in North Dakota. And at that point, the horizontal technologies were just coming down from Canada. So it was very early. Didn't have gamma ray while we were drilling. And it was a lot of, all right, let's circulate samples, see what we have, and make a decision on what to do. Since then, I've worked, I was grateful for the training Conoco allowed me to have in the unconventionals, and I've worked unconventionals almost every day since then. I will use unconventionals a little bit differently. From a reservoir standpoint, the unconventionals are the shale plays. However, we also have, kind of in what I do, we also consider the tight gas sands where we drill long horizontal wells with multi-stage fracture stimulations. That's kind of part of what is unconventionals also. And the technology in these plays is, it's mind-boggling. When you get in to see the things that we are doing and how we can place a wellbore out 30,000 feet away from us, it's pretty impressive, and the technology is growing every day, and it's unbelievable. From my standpoint, I've worked unconventionals in China, Australia, almost all here in the Powder River Basin, because we could go to other basins. I've worked Haynesville, I've worked Eagle Ford, other basins, but Powder River Basin always has what we need, and so do the other basins. And then it's just a matter of economic when we choose which one we're going for and what opportunities we have. So in my business right now, I'm probably 90% of my time is in unconventionals. And so some of the important things we have, you heard the governor state that regulation is very important to us. It is very important to us. And he made a good observation that in the past, regulation was to help us do things better or to make sure we do things better. Today, it's used as a way to keep us from doing things in many cases. I think a part of that is because of communication. In these industries, we're all very highly driven, and we're putting our head down trying to make a bottom line, trying to meet that bottom line, and we don't spend as much time as we maybe need to help educate the public and to work with regulators to understand. We understand what you're trying to achieve here, but the requirements you're imposing on us are, one, not feasible, and two, really make this uneconomic. And then just one last piece that runs a lot of what I do is kind of a side, oil and gas is what I do. We need to produce oil and gas. Water controls everything that we do right now. It's access to water and the ability to treat the water and dispose of it when we're done. So even though I'm an oil and gas geologist, I spend as much time dealing with water as I do with producing the commodities.
Yeah, thank you for that. So it's interesting. I like that piece about communication because, like I said, this is a unique opportunity. When in Wyoming, we have the opportunity to go and talk to somebody instead of try to get things, over email or something like that. So that's a really great insight. The next I'm going to ask Tawfik to introduce himself, please. There's a microphone right there. I think you have to.
Good afternoon, everyone. Can you hear me? So thanks for having me today. I just finished my class, so if I put my teacher's hat, please forgive me. My name is Tawfiq, and I've been with the University of Wyoming for 7 years. I've been teaching mainly for 5 years. I managed a drilling and completion simulation facility. It's one in kind. So if you think about anything that relates to drilling, we would love to have you at that simulation facility. 2 years ago, I started doing the research, and I was fortunate to start working on the Mowry Shale project. And before I dig into the research itself, when we say drilling, many people think, oh, it's only oil and gas. We all have different interests in subsurface resources, and the common thing between all these subsurface resources, you either have to mine them if they are near the surface, or you have to drill wells. We heard the governor today talking about 3 miles laterals, and those are challenging to drill, but we want to push the envelope and actually drill further than that. So drilling takes a lot of engineering, a lot of design. It's an interdisciplinary problem that requires mechanical engineering, electrical engineering, geology, all petroleum engineering, chemical engineering, all disciplines actually to work together to achieve those long laterals. So we can make unconventional resources economical that way. So again, drilling is not only for oil and gas, it's all for underground resources that we can achieve by drilling efficiently and economically, but we also want to be very careful about the environment. And I like what Andy mentioned about water. Water is a very valuable resource. We need a lot of water to drill. We need a lot of water to stimulate wells, and it's very valuable. So if we can get to recycle water or reuse formation water, which is some research we're looking into, to drill the well, frack the well, even use it for enhanced oil recovery, that will be very economical and very valuable to the state. I really like to come to drilling engineering from interdisciplinary perspective. In my research group, for example, I have students with mechanical engineering background, chemical engineering background, and we collaborate with professors from geology, we collaborate with professors from civil engineering. And I keep telling them this, and I wanted them to blame me on the formation damage. When you drill a well, you take for granted the fluid we put in the well is the best option. But sometimes actually the drilling fluid we put in the well might cause a lot of damage unbeknownstly to you. So let's work together. You tell me what's the outcome you want to achieve, then we can back engineer the drilling fluid, work on the chemistry that will stimulate the formation even better, and it doesn't cause the same damage. So for example, the Mowry Shale we're studying, I'm collaborating with other research groups because they are interested in geomechanics and geochemistry. And I keep telling them the fluid we put in there, usually oil-based mud, let's study the chemistry together and let's engineer that in a way that facilitates a stimulation, not causing formation damage. So we love, as Tim said earlier, we are very close to each other. We can collaborate with other disciplines very easily and solve this problem. We can just walk to each other's offices and chat about those problems. So at the University of Wyoming, we love to solve real problems. And to the best of my knowledge, when I was doing my undergrad, the best professors I remember were not the one that teaching straight from the textbook. Raise your hand if you missed the professor who was teaching straight from textbook, right? So you want to work on real world problems. The challenge I face as a professor at the university here is when I want some samples, let's say cuttings, it's very hard for me to get those. I can't go to Walmart and get them. I have to get them from a company. So companies needs to help me educate the students who are the future workforce. So sometimes we need drilling data or some samples, fluid samples, that we can get the students actually to use in the research. So if you have samples, I'm going to go around and pick them up.
Well, Tawfiq, let me introduce you to the person sitting next to you, who is the Vice President of Subsurface and Powder River Basin at Anschutz. So Joey, please introduce yourself.
Sure. Thank you again for the introduction, and someone construe being promoted to operations. Yeah, it was kind of interesting. No, I say that just breaking the ice. I appreciate that. Yeah, subsurface. So a little bit about me. To your point, I started my career actually working for Exxon. I guess the diversity here is not as diverse as we think. Back in the late 90s and carried over into ExxonMobil, and then spent
a little bit of time, kind of in the late 2000s, teens, kind of decided I wanted a little bit more entrepreneurial. I'd spent some time at, a super major, some would say the super major, and went to a few different smaller companies. And now I've found myself in what could be considered the poster child for a small company. AEC, not the Atomic Energy Commission, but Anschutz Exploration Corporation is a very small company, at least in the physical sense. We're about 100 people, but we think, and we're very proud, of our capital provider, Mr. Anschutz, a wonderful individual, but also just the company itself and what we have been able to achieve with such a small crew is pretty incredible. A little bit about that. I mean, we're a major player, number one oil producer in the state of Wyoming. We're very proud of that in a very controlled sense. All of that is from the Powder River Basin. We very much believe in that basin for a host of reasons, which I think we'll get into on this panel. We have right now about 460,000 net acres in the Powder River Basin, so pretty significant leasehold with an appetite to grow that, and I firmly believe we will do that. We talked a little bit about, Governor Gordon talked about extended reach or 2 and 3 mile wells. We operate about 270 active horizontal wells right now. We also have interest in about the same 270, 280 non-operated wells, so pretty significant kind of span of control, if you will, over producing assets. We're very proud about that. My counterpart on the operations side, Bill Knox, we do a lot of collaboration and thinking through how to drill those very expensive wells successfully. If we're not successful, let's just say Mr. Anschutz isn't very happy about that. Neither are we. We're also pretty excited. Mr. Anschutz kind of started his career, if you will, at least insofar as the oil and gas piece of his organization, as a wildcatter, and he's a fascinating gentleman. Last week, I had the opportunity to be walking down the road with him one early morning. We were at a kind of an executive offsite, and we were just talking about wildcatting dreams and things of that nature. In addition to the Powder River Basin and operating in Wyoming, we also operate another 400 to 450,000 acres, net acres, across Utah, a little bit into Montana and Colorado, and again, with appetite to grow that. So we're a very ambitious in a good way company, and largely driven by Phil's leadership. Going back a little bit to my career and then kind of coming home to where we are today, or where I am today. I'm a geoscientist by background, but I've spent a pretty varied bit of time kind of bouncing, very technical roles through the companies, very commercial roles and leadership roles. And I have to tell you, and I'm not saying this just because our reservoir and geo managers are sitting at the table with me, they joined me today. Anschutz is pretty special. It's special in that we're very familial, and we're a conglomerate of very, 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 very intelligent people, if I do say so myself. And so, I smiled a bit when you were talking about collaboration. One of my colleagues sitting at the table would call me we'll just say a manic collaborator. It's one of the things that I hope we can share with the students, but collaborating is extremely important. The oil and gas industry and certainly on the subsurface technical side is very complex, and no matter how intelligent an individual is, the collaborative nature between those individuals on engineering and geoscience, you just can't beat that kind of teamwork. So the last thing I would say is it's been a pleasure I have the honor to lead our engineers and geoscientists, but I also have the land, regulatory, and government affairs. So the notion of regulations and kind of government affairs work, it is very important to us, and we take it very seriously. And I'd end with the notion of what's important for Anschutz. Two words come to mind: relationships and results. And on the relationship side, we spend a very significant amount of time getting to know our landowners, our partners in land. We need to be respectful in thinking through how we operate with those partners in mind. We spend a lot of time with the federal, the BLM. We spend a lot of time from a state perspective. Just earlier this week, our director of land regulatory and government affairs and several of her folks were out with state senators and things of that nature, touring our facilities and what we're doing in the Powder River Basin. And that's what I mean. We spend a lot of time building those relationships, and we understand that isn't just an investment. It's a mandate. We're not in this together, and that's extremely important. The other piece on results, I'll speak a little bit back to the integrated nature of the team that I have the honor to work with, whether it's geoscience or reservoir. We spend a lot of time really thinking through before we ever go and drill a well, the science, and we do it on a very, very, very basic level all the way up to very complex level. And then we constantly reassess with ourselves on lookbacks and things. Did we get the success we wanted? Was this an ambiguous result, or was this a failure? And then we learn from the failures. We try to adjust for the ambiguity, and we celebrate the successes. Sometimes I get told, well, we don't celebrate those successes enough. But I also think that the overall results that we're seeing with Anschutz, particularly in the last, we'll call it 2 to 4 years, we came out of the pandemic and we've increased our liquids oil production by over 40,000 barrels a day in just 4 years. And a large part of that has probably occurred in the last 2. That's a significant outcome for such a small company, or any company by that matter. We're delving into some of the formations and things that exist in the Powder River Basin, which makes it special, and we'll talk about that as well. Some of them more difficult to assess and drill and produce from than others, and some of the formations that are a little bit leaning toward more of the difficult. We're actually seeing some significant successes and getting some publicity that we don't necessarily want. We're getting tweets, or I should say X's, I think they are, and things of that nature on some of our results, and we're very excited. And I go back to that word proud again about that.
Yeah, thank you so much for that, Joey. One of the things that drew me to unconventional resource as a researcher was that even though we're increasing production a lot and we have a lot of production, we're still only getting this very small amount of the actual oil out of the ground. And so there's a lot of room for technological development in this area. And so I want to focus on that next. So, Andy, I'm going to ask you, from your job as a consultant, what kind of technologies are you seeing in the industry, in the unconventional world, that you're excited about? That, or if you want, what do you see as the kind of the next thing that needs to be developed?
So as most of the people here today have said, we think about, I'm a geologist, so I'm interested in the rocks. Well, that's just a very small piece of what it takes to produce oil and gas. And unconventional is code word for reservoir or difficult to produce. And so the technologies are unlimited. Just from the time I started drilling horizontals in the 90s up until now, just the advent of Pason or Todco, which delivered data to us from the well site. We're about 6 seconds behind what the well site is seeing. And it will literally transmit to us hundreds of different channels of data. And that's done things like, it's really, I think, had a big effect on the drilling technologies to where we can tweak some things pretty amazingly down in the subsurface now, all in an effort to get a better connection to the reservoir, to hopefully reduce potential reservoir damage, because as Tawfik said, we do damage the formation when we drill it. With respect to the damage in technology, everything technically we do is really important. The production systems we use and the well bores are extremely important to lift the fluids out of the well bore. And none of this happens if any one of these pieces falls down or fails. So with respect to the reservoir now, 100 years ago, we could touch an amount of rock. What the new technologies have done for us is it's dropped our permeabilities that we can access about 1 million times. So now, if we have a little bit of reservoir damage, permeabilities we're moving fluids through are similar sizes to the molecules we're moving through that permeability. And so a little bit of permeability, it can be the difference between production and not production. And so that's why the drilling technologies, the completion technologies, those are really important. Basically, what I would say is there's unlimited technology that we're developing and that we can continue to develop to do better than we are now. Another big one is just moving our gamma ray from 40 feet behind the bit to now. I just drilled a well where we were 1 foot. We were directly on top of the bit. We were getting gamma ray data at the bit. Now what we need to do is make that more reliable. Because when we run the gamma ray goal by it looks different sometimes. So,
just to further, I saw a great talk at Image just a couple weeks ago where they have acoustics on the pipe, which is like such a neat new technology. I think that's such a cool thing. So like I'm a bit of a nerd when it comes to these things. So pardon me for getting super excited about acoustics on the pipe. Yeah, it's kind of weird, but Tawfik, you're educating the next generation of oil and gas professionals. Can you talk about the ways that technology is being taught? And like, we hear a lot about machine learning and AI. If you could briefly, I know you're involved in that as well. Could you talk a little bit about that as well?
Yeah, so I chose to be in academia a long time ago, thanks to my dad. So I take pride in educating the future engineers. So we start by teaching them the skill. Knowledge comes with the job. You're going to accumulate a lot of knowledge, but skills like problem solving, critical thinking, decision making, leadership, communication, it takes a big part of what we do. So I strongly believe in active learning. For that, we have the state-of-the-art drilling simulators where I teach almost all my classes. And anytime we have a concept in the lecture that needs hands-on, we jump on the simulators and practice together. So, and if we need to do machine learning, we can actually use a simulator to create a scenario where we can create synthetic data if we don't have an actual data, for students to practice how to use machine learning to optimize the drilling operations. But also on the other side, I don't want you to think that the future education is only simulation, it's only virtual reality and augmented reality. There's a lot of hands-on lab work that I want students actually to gain the knowledge. And when we talk about formation damage, and as Andy was saying, a lot of it goes back to the drilling fluid. Are we going to use oil-based mud because it's working, it's not broken, let's not try to fix it? Or are we going to be environmentally friendly, conscious, and try to switch to more environmentally friendly fluids? Fluids that will do the same job but are more friendly to the environment, like water-based. Can we use formation water to do that? So I also want students to be in the lab using the same fluid, the same formation that we have in Wyoming, so they can think of this. And the best question, the best comment I get from students that I never thought of it that way. So now I get them to start thinking about coming up with solutions, and I know they are capable of that. The new generation is not lazy. They are on their phone, but this is how they operate. They can be on their phone and they can be thinking at the same time. I don't know how they manage to do that. My son always impresses me with this, and my students too. So maybe we can make some gadgets for them. Maybe we can use some machine learning to help them. Here is a tool. We have experts in the room. We can collect all this experience and actually put it in a machine learning gadget like ChatGPT, for example, but it's specifically for oil and gas. That would help this generation to gain the previous knowledge that we accumulated over the years, but also deliver it to them the way they like to operate. They are more hands-on than many other generations. We used to be excited when the professor started using the textbook, but so far, no, I didn't get any student excited if I say when I read from the textbook. I don't do that. But just as an example, students like that, don't like that anymore. We also do a lot of outreach. Since we have the simulators, we can mimic a lot of scenarios. If you're talking about carbon storage wells, we can do that in the simulator. We're talking about geothermal drilling wells or geothermal energy, we can mimic that on the simulator. And we get K-12 students in that room and try to bring basically the message that we've heard here today about integration. Let's not think about elimination. We can actually collaborate. Subsurface expertise coming from oil and gas can help geothermal, can help carbon storage, let's not eliminate, let's integrate and work together. And the room that we have, the technology we have there, actually has been very effective for the last 7 years. I've been with the university in delivering this message to K-12 students, and I always get questions. We never thought about it that way. Oh, it's the right environment for you to think differently, because if you want to change the future, it starts with education.
Thank you for that. That's great. We can do all the research we want at a university, fundamental scientific research. It's so important. But Joey, I want to ask you, how does a company like Anschutz take that fundamental research and apply it to the real world problems that you're facing on a daily basis?
Well, the first thing I'm going to say is I think I'm having a professional crush. I'm hearing so many similar words and thought processes and things from Tawfiq that I keep near and dear to my heart, and also talk a lot with my team, and my team talks with me. So anyway, I say that with respect. It's a little bit of a tricky question. I'll remind you, we're a 100-person company. Out of that, the petrotechnical engineers, geoscientists, and I'll loop into that the completions and drilling engineers. I mean, we make up about 50% of that, and so to do that math for you, that's about 40 to 50 people. And we don't have a heck of a lot of time to do our own internal research. And so I like the question because it is thoughtful in the sense of how do we then either partner with universities such as University of Wyoming, which we're hoping to do more of, or with partners in, say, like drilling companies and things of that nature. We do a lot of the latter. We're trying to leverage other, third parties and things. I'll hone in on a specific example and give a shout out to our drilling organization. Fantastic organization, is doing great things and drilling very difficult formations. But more recently, if you look at some of the statistics, if you're a nerd like that, drill times in the Powder River Basin historically have been pretty high, on the order of 20 to 15 day type spud to rig release times. We're drilling wells now, and more recently we've set some records that are sub 8 days and kind of a 7 on that front end, and we feel like we probably have line of sight to maybe get that down another day or two, which is just significant. I mean, the roll-on effect of that is, and doing it safely, is we can start to bake that into our development plans and think about the cost savings that roll down the increase in wells that we can bring into a fiscal year in terms of our development plans, et cetera, et cetera. So that's an example of, we partnered with drill bit companies and drilling companies to think through kind of the physics of how the bit is interacting with the formation, the physics of all of the drilling parameters of weight on bit and rate of penetration, what our mud system looks like, and the lubricity of that relative to the formation, tweaking those things and being very, very thoughtful as opposed to just putting dumb steel on the ground. So it's fascinating. When I think of technology in general, and particularly being a more subsurface-minded person, I mean, it spans the gamut. You mentioned, we talked about gamma rays and acoustic tools, the tools we put on drill strings or the tools we run in afterward on wireline. I think about the initial panel that we had today in terms of material sciences, and whether it's mud systems or the steel or geophysical or petrophysical approaches we use. I think too often, and this is another comment back to the students, is that some people think the oil and gas industry is a bit of an archaic industry, and I would argue that it's probably more technical than anything Elon Musk owns. There's a lot of technology that comes to bear, so on and so forth. So to get back to your question, I mean, AEC, we leverage a lot of third-party components, but again, we have a lot of talented people who sometimes technology and advances in technology doesn't have to necessarily be super breakthrough. It's taking some of the fundamentals and kind of tweaking those, going to your point about teaching the basics and really applying that forward and kind of allowing for true technologies to be better understood in the place of the basics. So
Yep. So when I was at Chevron, I was part of a multidisciplinary team that had multiple different types of engineers, geologists, and what was neat about it was we had our financial team as well. And that's something that, is not often thought of, but really kind of the finances do kind of drive the industry. Well, they do drive the industry, kind of. And so being able to work on that broad of a team was really important for me and my development when I was a young scientist and even today. So I think that's really great insight. One thing that we touched upon, and I didn't prepare you guys for this question, so this will be interesting to see what your answers are. You two, Joey and Annie, talked about both having worked for Exxon. When I was in an undergrad, we saw the mergers between ExxonMobil and Chevron in Texaco, and we've started to see another spate of that, another round of that recently with Chevron acquiring Noble, with Exxon acquiring acquired Dip. From a competition and industry standpoint, is that a good thing for the industry, or would you like to see less of it? Then it's okay if you don't answer, because I don't know if this is too much of a political question or not, but just your kind of views on that.
Happy to chime in. I think it's interesting your finance, kind of component. I think there's a healthy tension in most oil companies. I've been in 6 of them in my career. There's always a healthy tension. Is it the finance side of it running the company? Is it engineering? Is it geoscience and anything in between? I would argue it's all of them, but it comes back to, and I did not coin this phrase, we're not here for science projects per se. We're here, from a capital markets and making money perspective. It is a business. So the finances are extremely important. I link that then to your question of, if I'm taking the question correctly, should the industry see more consolidation of companies and things of that nature? I'm not saying anything that is earth-shattering here. There are plenty of the Enverises of the world and various banks that come out with their thoughts on this. And I would side with it and say, yes, I think there is a lot of room for consolidation. It helps with efficiencies, and I would argue even with the consolidation, some of the competitive nature of just the way that then the companies would interact with, kind of the more support functions, the logging companies, the fracking crews and things of that nature. And there's also just a lot of, I think of it from a business development perspective of companies out there, particularly on the private equity side, that I feel like there's a new meaning to the word of stranded resources, where you've got private equity companies who, aren't doing much and in the way of bringing resources forward, and, expectations of pricing and things of that nature to get deals done. I think it's very difficult. And so I'm not an expert in the arena. We have wonderful people within Anschutz that think all day long about business development and how to do those deals. But there certainly are some additional challenges in that space. So I would say, yes, I think there's room for consolidation.
Yeah. Andy, do you have any comments?
So being a consultant in my last 30 years, what I do as a consultant changes every 3 to 5 years. What the industry needs for us to provide is different, and it's constantly evolving. And it has to do with everything that affects the development of minerals and the state of the economy and everything. So when early on, when the unconventionals and when the horizontals were really starting up, we did a lot of work for a lot of big companies, because at that time we were coming out of the 86 bus still. That bus lasted for 20 years. So we were coming out of that to where there were not a lot of large staffs within the oil and gas industry. And so we would do a lot of work for bigger companies. We would work for Exxon, for Shell, those types of people, and did a lot of work for companies like Devon while that was happening. Then starting in about the 2000s, when the environment got more friendly for these bigger projects, and we moved from maybe smaller projects into larger 60 to 100,000 acre projects, the companies that were doing most of the drilling started staffing up, And so we lost all that work, but it also created a space for the smaller companies to come in and fill niches, and we did a lot of work for them. And now what we've seen in the latest downturn since 17 and since 2020, we kind of have more of a mix to where we're working for, we've worked for the largest companies in oil and gas in the last year, and we've worked for individual mineral owners. So the answer is the market's going to force change, and an opportunity always develops.
Yeah, so be on the ball, right? That's kind of the key there, right? So before we move on to the questions from the audience, we have a great and diverse group of students here. So I'd just like to go through the list here and ask for your wisdom and your advice to the students as they, move from their studentship into industry, or if they want to go into academia, or whatever you have to say to them that's going to help them on their way. We'll start with Andy.
Yeah. So what I would say is I kind of have three things. First, with anybody, make yourself indispensable. Make yourself so that whoever you're working for can't afford to get rid of you, because they will try to find a way, especially when things turn down. Step two, or another thought I have is don't get lost in the trees. Especially as a geologist, we really like the rock. We want to know everything about the rock. Nobody cares about the rocks. Your clients care, or your constituency cares if you're helping them in moving their cause forward. So the rocks are great, but don't lose sight of, I found 1 billion barrels of oil. Great, we can't get the lease. So you have to keep your eyes open, especially in the environment we're in today. We've got a lot of uncertainties and a lot of changes that are going on, and you need to understand what's going on the bigger stage and understand how that's going to affect what we potentially do in the future. And then the third piece is there's always opportunity. You have to find it. How can this opportunity isn't being met. How do I get myself in a position to make that valuable to somebody?
Joey?
I'd start by saying I'm a dad. I coach my son's football team, and I coach with another type A individual. I'm a type A. And that person is very aggressive, and I have to remind the kids all the time, let's also have fun. So the first thing I would say to the students is don't lose sight on having fun. Whether you're a geoscientist or an engineer, learning is fun, applying it is fun. I say words that I learned the first day I ever stepped into a geology classroom, so on and so forth. I drive down the road, almost running off the road, looking at outcrops. I was doing it this morning as I was driving from Denver. So have fun. I think that's extremely important. We can get too serious about ourselves or the environments that we're in, and that becomes toxic. I think in terms of preparation though, for whatever industry you're going to come into, I think it goes part and parcel with make yourself indispensable. I'd focus on 3 words. One would be an integrator. I'll pick on geoscientists. Sometimes we find, well, I'm a structural geologist or I'm a sequence stratigrapher. And when I joined Exxon, there was a time period where there were these families within the geoscience part of it, and people were running to stratigraphy or running to structure. I ran to this thing called mature field development because it was an integration deal. So that's been kind of core since I began my career. Integrate. Work with your engineers if you're a geoscientist, and vice versa. Go to the ag department and understand, what does land mean? Because it's extremely important. Things of that nature. The other one would be an iterator too. We talk a lot at Anschutz about opening the aperture and divergent thinking, convergent thinking. Don't get fixated on a single model. Learn how to think logically, learn how to think about multiple scenarios, and test yourself. And I'm fixated on a particular problem. How can I prove it wrong myself? Those sorts of things. Those 2 I words would, I think, make new students going into companies and or hiring scenarios very, very valuable. The last is my favorite word because I'm a radical collaborator. Work on collaboration, like seek it out. If you're a student, do team projects. If you're a professor, force team projects, things of that nature. I think collaboration makes us all superheroes. That would be my recommendation.
Great. And topic?
So I don't know if it's fair for me as an educator to say that to students because I say that all the time. So, but I just want to mention a quick story. I was at an educational conference one time, and we had to work in pairs. And the teammate at that time learned that I have petroleum background. And after some discussion, she started opening up and telling me, when I learned that you are a petroleum engineer, I was very concerned because the information, the environment damage and everything you do, but you seem to care about the environment. I was shocked because it didn't occur to me to share with people around me that I care about the environment. So I started actually changing my teaching philosophy to teach students the 3 E's. Engineering, those are the skills: communication, collaboration, energy. That's because we never heard that we need less energy. We always hear we need more energy. So they have to learn about how to extract the energy. Then ethics. I start teaching ethics in my classes. Even in the outreach, when I get high school students in the summer, I talk about ethics. We care about the environment. We care about the society. So we need students, our students need to share this message with their other friends, and that we care about the environment, we care about the society. We are in the energy business because we care about the society. We don't want the society to suffer from less energy because we know we need the more energy. So to sum it up, the 3 E's are engineering, ethics, and energy.
Yeah, thank you, Toffee. That's a really important thing. As we advance technology in the oil and gas industry, it not only helps produce more oil, but it helps us do it more efficiently and with a smaller footprint. And I think that that's really cool that we get to do both at the same time. So now we're going to open it up to, do you want to?
No, I was just, if you have a question, write it on your card or paper, hold it up, and one of the student runners will bring it on up to the moderator.
Yeah. Okay. So here's a question that I was going to ask if I had more time. So I'm glad that somebody else brought it up. So this is specifically for Joey, but I think that the other two people up here are more than qualified to answer this as well. Industry's research needs tend to operate on timescales that are much shorter than graduate student careers. How do we overcome this hurdle? Well, we'll start with Joey since his name is on this one. So.
Yeah, that's a tricky one. In fact, it's reminiscent. We've had some early discussions with the University of Wyoming, which again we're very much looking forward to progress that forward on, say, the Maui Formation and some of the work you guys are doing there. We're obviously operating and starting to work within the Maui and seeing some successes. But you're right. I mean, we think on quarterly bases, thankfully at a private company, not from an earnings perspective, but just from a workload and things of that nature. So it's a tricky one. That's not a real great answer. It's not an answer at all. It's a statement to the question. What I would say is we just need to communicate and talk and think about, how can we help? Is there, can we give you cuttings? Things of that nature? Are there smaller scale, both, mainly on the time frame problems that we have that could help? And we also need to be open to the notion, by we, I mean the industry, open to the notion of, hey, providing data and things of that nature that can support longer term research, just finding that balance.
And I'm going to turn this on its head a little bit as well, because one question, and Andy and Tawfiq, maybe you guys can address this one, is what is 5 to 10 years down the road that we could start doing research on now that could help? And if you don't have an answer for that right off, we can ask another question and you can think about that and maybe I'll come back to it. Because here's a good one. As a Bachelor of Science level, is it better to stay multidisciplinary or more focused in coursework and summer job skills? And if you don't mind, I'm going to start this one. When I was an undergraduate, I was a history major. I didn't become a geologist until, I don't know, about 3 or 4 years after I was a sports journalist. and then I became a geologist. What I found important when I went to became a geology graduate student was there's two things, and can't remember which one of you focused on this, but it was do what you love. And that's what I did. I did what I loved, and then have an open mind. That's the other thing that I found, because when I was in graduate school, I was a mathematic crystallographer of soil minerals. I had no indication that I was ever going to join industry. And then I got approached by a mineralogist at Chevron, and it turns out that, wow, they were doing research on the thing that I was actually interested in, and I never thought that I would go into that. And it led me to a completely different career than I ever thought. So those are my bits of advice. But at the bachelor's level, what do you think? Is it better to have a broader range of education, or focus more on this summer job skills and classwork? Andy, I'm going to let you talk about it.
Yeah, that's interesting. When I was coming through school, I knew I wanted to do exploration. That's what I wanted to do. I wanted to look for oil and gas. So I was pretty focused, and I knew where I wanted to end up. And so I kind of ran my undergraduate and my graduate career into that. Then when I got out into industry and started working, I undid all that. I had to learn as much as I could about every piece of the industry that I was working in. And so if you have, it's not an answer, but both paths are good. But I would say doing what I do, I benefit by knowing more things. I'm reading all the time. I'm on YouTube looking up geologic seminars, because I can be of use to my clients by knowing as much as I can about everything. So trying to pigeonhole yourself, because that's great right up until the time your company doesn't need that.
Thank you for that. That's great. So let's get a little bit more specific here. We at SER have a very large research project on the Mowry Shale right now. It's unconventional resource. What are the important scientific challenges that we're facing in development of the Mowry Shale, which has quite a bit of resource there? And Tofik, I'm going to let you start, because you're actually one of the professors working on this project right now. So
if I just can add a little quickly about the previous question, I have what I call the T model. So don't limit your options. Keep your options open. Go take an internship, try other classes, go learn something different, because you never know what is your real passion until you find it. So if you limit your option from day one, you have no idea. Then once you find your option, you build vertically on that. So you reach out, then you stand out. That's the T model I like to use. But to your question about the Mowry, I believe the industry can tell us more about that. But one of the things I like to bring to the students' attention is when we add Wyoming bentonite at the surface to the drilling fluid, it creates unique fluid properties. But when we drill into it, that's causing lots of issues. And many of the students didn't think of it that way, because they said, oh, bentonite is great. We drill into it, we get better mud. No, it doesn't work like that. It has to be an addition. You're adding it intentionally. You have to study if it's impacting the fluid in a positive way or negative way. Then we start studying in the lab the difference, wettability, water width, oil width, and all of these fun problems to solve in the lab. So the Mowry for us is challenging when it comes to building the optimum drilling fluid that will not only make drilling efficient, but also will facilitate better fracking or better stimulation and better production rate. Then after that, when we start doing EOR, enhanced oil recovery, to formations like the Mowry, we want to make sure we did not cause harm at the beginning. And what we did was enabling everything coming after that. So as our colleagues were saying, it's about integration. We have to talk to each other. If we need to do something 20 years from now, we have to plan it from today. And my understanding, to get to the formation, you're going to start with drilling. So you start with us. So better tell us what you want, so we can build a hole that will be stable, that will last longer, but also will facilitate everything comes after that.
Yeah, Joey, do you have any comments on that, on the Mowry?
Yeah,
A quick comment to what could be researched 5-10 years from now. I think the notion of enhanced oil recovery in nano and micro Darcy type rock would be a very, very advantageous thing. So I'll just put that one on the table. With respect to the Maori, I hate to be this cliche. I'm going to purposely be a little bit vague here. I will say that we're excited about the Maori. I think the Maori has challenges, and those challenges fall into a few different buckets in the sense that you've already kind of alluded to. It's hard to drill. Some would say unless you have the right team. I think it's pretty enigmatic, even though we tend to think about resource plays, basin-centered hydrocarbon source rocks as being somewhat homogeneous. I had a great mentor in my early days of my career. Out of respect, I won't say his or her name, but very much into mudstones, mud rocks, which sometimes are shales. And his famous, sorry, I spilled the beans there. His famous component is that mud rocks are not boring and they're not homogeneous. And I think there's a lot to be learned, whether we're in the Maori or the Nio and those sorts of things, going back to some of the fundamentals. Where I'm going with that is, I think there are some fundamental things from a geoscience perspective, geomechanical perspective, in terms of the heterogeneity and variability laterally and vertically in something like the Maori. And I would go so far as to say also that heterogeneity of what's above and below it. So, yeah, I'll just stop there on the Maori.
Yeah, so in my career at Chevron, I got to work on, 8 or 9 different unconventional resource plays, from the, Cook Lake Fajita, Marcellus Shale to, the Green River, right? And they're all different and they're all fun in that way because they present unique scientific challenges that you have to overcome. And so, it's fun to work. It can be frustrating too at times because at some point you just be like, oh, why can't you just all be like nice sandstones and you get a lot of oil out of it? All right. So here's a question going back to the water issue. Can we use produced water for fracking, or does it have to be fresh water?
Yes.
That's my favorite answer of the entire. But Andy, you have any comments?
I agree. Yes.
So it depends on the chemistry, right? I mean,
this for drilling fluids. I think that's the question we're also trying to answer, because that might save us a lot of diesel oil that we have to use, and instead we can use the formation water.
All right. And then one last question here. What would it take for the Powder River Basin to compete with the Permian Basin for attractive?
Okay, so one of the things I wanted to say here is the Powder River Basin is unique because we have all the large unconventional basins. We've got the Permian, Eagle Ford, the Niobrara, Haynesville, Marcellus, and then we've got the Powder River Basin. The Powder River Basin is extremely underdeveloped, and a lot of that has to do with the ownership in the basin and the access to facilities. So in my opinion, I would say it's not going to be like the Permian because we cannot develop it at the speed that the Permian has been developed. However, with respect to impact and the amount of oil we can produce, we have a lot of resource in the Powder River Basin, and a lot of, I would say one good thing with as slow as we're developing, we can't drill 100 dry holes. We're going to learn from mistakes we make and get better from each well that we drill. So in one sense, it's good that we're developing slower, but we just don't have the ability to develop as fast as we do in other parts of the United States.
As apparently I do often, I'll start with a little bit of a comment first, which is back to the students. There's 2 words that come to my mind here, and I'm using this as a preface to what I'm about to say. Humility and confidence. As a student, I think back when I was a student, I'm not sure I had a lot of either one of those things, and that can be in conflict. But over my career, I've learned how to become more humble, learn from the failures, learn from the ambiguities, things of that nature. But confidence is extremely important, and confidence can be construed as a lack of humility at times, things of that nature. So again, just a couple little tidbits for the students. What would it take for the Powder River Basin to compete with the Permian? So I want to be clear when I say this. This comes from a place of confidence, not a lack of humility. I think it's going to take the right operator. I think there's a lot that operators could do to improve. Things of that nature. The Powder River Basin, in my humble opinion, has a lot of hallmarks that are very similar to the Permian. There's a lot of stacked pay, maybe not at the same spacing, but there is a lot of opportunity to really think through, if I reverse engineer this, a good development plan and everything that has to happen to get you there. So I go back to, thinking through as a good operator, whether it's the operational approaches and the technology that's brought to bear there, or the ingenuity that's brought to bear there, whether it's the subsurface environment, thinking through, let's not skip over the basics, keep the aperture open and think through how to do things, the relationships that I mentioned earlier in terms of how to build those in the basin, and it's important in the Powder River Basin, those sorts of things. So I think it comes down to a good operator.
And with that, we're going to have to end our session. So sorry about that topic, but the problems are there, they're real, but we are well poised to address them and meet them head on. So thank you all for your attention. Thank you, panel. This has been great.